Example 1. The accompanying table lists body temperatures in degrees Fahrenheit obtained from randomly selected subjects. Use a 0.05 significance level. Test for an interaction between gender and smoking. Test for an effect from gender and test for an effect from smoking. What do you conclude? So here we have our row factor, which is gender. The column factor is smoking or does not smoke. And then we have our value in the last column. Okay, so the requirements. The normality. For each cell, the sample values come from a population with a distribution that is approximately normal. This procedure is robust against reasonable departures from normal distributions. Number 2, variation. The populations have the same variance or standard deviation. This procedure is robust against reasonable departures from the requirement of equal variances. 3, sampling. The samples are simple random samples of quantitative data. Number 4, independence. The samples are independent of each other. This procedure does not apply to samples lacking independence. 5, two-way. The sample values are categorized in 2 ways. And 6, balanced design. All of the cells have the same number of sample values. All the requirements either are satisfied and can be reasonably assumed to be satisfied or do not apply. The calculations are quite involved, so we're going to use technology. We're going to use StatCrunch to determine the two-way analysis of variance. We're going to enter all the sample values in one column named responses. We're going to enter corresponding row numbers or names in the second column named row factor. And then we're going to enter the corresponding column numbers or names in the third column named column factor. We're going to click Stat on the top of the menu. Select ANOVA from the drop-down menu, then select two-way from the sub-menu, and then select columns to be used for responses, row factor, and column factor, and then click Compute. So what I've done here is I've come into StatCrunch, and I've generated the information. So let's take a look. So here we have our row factor, we have our column factor. Now our value can be the same as the responses. So we can either say value or responses. So we put in our row factor, female smokes, there's a value, female smokes, there's the value, female smokes, and there's a value as we continue forward. Now we want to test whether there is an interaction effect first. So the null hypothesis is that body temperatures are not affected by an interaction between gender and smoking. The alternative would be that body temperatures are affected by an interaction between gender and smoking. So what we're going to do is we're going to go in here and we're going to click on the following. So we have our data. We're going to go to Stat and then scroll all the way down to where it says ANOVA and then select two-way ANOVA. Now the responses are in the values that we created with that third column. The row factor represents the row factor, which is the gender, and the column factor represents the smoking or non-smoking. And then from here we just need to select Compute. So I'm going to go ahead and copy this information. Okay, so using this information from this table, we're looking at this column that represents the mean squares, which is MS, and therefore this is the column we want. Okay, and then what we're going to look for is the following. We're going to take the mean squares of the interaction. You can see here the mean squares of the interaction is 0.16. And then we're going to divide that by the mean square error, which is 0.24125. When we divide those two numbers, we get a test statistic of 0.663212435, which is written here, and then rounding it to 2 decimal places gives us 0.66. Okay, now to the right of that, you see how we have interaction here. You can see that the p-value is the last column. Well, the p-value is 0.4313. So remember here that we reject the null if the p-value is less than or equal to 0.05. we fail to reject if the p-value is greater than 0.05 being the significance. So if we take a look at the p-value, we can see here the p-value of 0.431 rounded to 3 decimal places is greater than 0.05. Therefore, we failed to reject the null hypothesis. So then we would say the following. We failed to reject the null, so there's insufficient evidence to support the alternative hypothesis. There does not appear to be an interaction between gender and smoking. Okay, so now we're going to take a look at the row and column effects. Because there does not appear to be an interaction effect, we proceed to test for effects from the row and the column factors. And the two hypothesis tests use these null hypothesis. There are no effects from the row factor, gender. There are no effects from the column factor, smoking. So let's proceed with the row factor. So the null is that men and women have the same population mean body temperature. And the alternative is that men and women have different population mean body temperatures. So we're dealing with the row factor, which is gender. So we're looking at this value and the p-value and the test statistic there. So if we take a look at this, we can see that the mean square's gender value is 0.36, and we're dividing it by the mean square error of 0.24125, which gives us a test statistic of 1.492228, which is approximately 1. Now we're going to take a look at the p-value, which is 0.2453. So we now see that the p-value rounded to 3 decimal places is 0.245. And since it's greater than 0.05, we also fail to reject the null hypothesis. So therefore we would say failed to reject the null. There is insufficient evidence to support the alternative hypothesis because gender does not appear to have an effect on body temperature. Last thing we want to do is the column factor. And recall that the column factor is smokers or non-smokers. So here we have the mean squares for the column factor, the test statistic, and the p-value. So the null hypothesis is that smokers and non-smokers have the same population mean body temperature, and the alternative is that smokers and non-smokers have different population mean body temperatures. So for the test statistic, we're looking at the mean squares for smoking, which is the column factor, which is 0.2025, and we're dividing it by the mean square error of 0.24125, which gives us a test statistic of 0.83937824. Rounding it to 2 decimal places gives us 0.84. So if we look at the p-value, we're going to round that to 3 decimal places. Rounding it to 3 decimal places, we get 0.378, and you can see that up here. And it's greater than 0.05. Therefore, we fail to reject the null hypothesis. Therefore, the interpretation would be the following. We fail to reject the null hypothesis. There is insufficient evidence to support the alternative hypothesis. Smoking does not appear to have an effect on body temperature.